Hello friends, I welcome you to this series of sessions. The topic name is calculation procedure for engine emission parameters and we are talking about part 1 here. Before going into the depth of the presentation, let me explain you my story around this and why I have prepared this for you. I thought sharing this knowledge in view of you getting this in shorter duration where in my personal life I have to put significant amount of time and efforts in understanding this complex methodology while reading a lot of material, referring various literatures and consulting multiple individuals. So digital media is nowadays great advantages to share the knowledge with mass community without much efforts. And this will also give me sense of service to at least those who will get benefit out of this. So here variable speed diesel engine for off-road application has been considered as an example, and we will try to calculate the cyclic level emissions for various pollutant like NOx, SC, CO and PM, and we will compare those cyclic level values with the emissions limit set by the standard. The great advantage of this tool is that engine designer can upfront estimate or assume some raw emission values, and using this tool he can calculate the cyclic level emissions and compare whether though these resembles with engineering target and the limits. So with the help of this tool, the developmental time and iteration time can be significantly reduced. So in the next slide, we will understand what is in it for you. From here onward, I am switching off my video due to size limit. Coming to second slide, we are talking about the content. So I am trying to develop your understanding and provide know-how on what are the input parameters and output parameters while recording overall engine and emission performance. Various engine and as well directly connected parameter to emissions are included over here. Output parameters also which are concerned to engine performance and emission parameters are also considered and calculated using the input parameters. The recording parameters is applied to various speed and load points which we consider in line with the ISO 8178 guideline towards either 8 modes for off-road applications like tractor or earth movers, or 5 mode for stationary application like power generating set. The formulation principle will also have been considered how cycle level average emission can be derived. I have split here in two major sections, even though we will have multiple videos in between. So right now we are going through part 1 and you will have thinking and understanding over whole subject after completion of these sections, and this will further enhance after completion of part 2 as well. So I am recommending to go through each slide in every video to have a very good understanding about the subject. Now coming to the section 1 subsection, I would say input parameter. So let us go through the input parameters one by one and we will discuss some brief information about some of the key parameters. Engine speed refers to the crankshaft speed in rotation per minute. You may be already aware about. Torque is force in rotation. Fuel weight measurement is done to calculate fuel consumption in hourly basis or in specific terms. This measurement can be in terms of gravimetric or volumetric basis. Exhaust smoke is in fuel smoke number, which is abbreviated as FSN, which will be used to calculate PM content, that is particulate matter content in the exhaust gas. Airflow is measured in terms of volumetric flow and can be converted with the help of respective density. CO2 and O2 contents are measured towards balancing calculations. NOx, nitric oxides, is a raw ppm further to process to get specific NOx emissions. Now coming to next slide, similar to Other emission parameter, hydrocarbon SC, is one more pollutant to be measured. This value will get converted to again specific emissions. You'll get complete understanding of engine performance along with emission performance as I mentioned earlier. Blow-by is flue gases escape from the piston, ring and liner areas. These parameters are again not taking part in emission calculation. We have to record various temperature and pressure at various locations of engine like intake and exhaust circuit. Oil gallery pressure is lubricating oil pressure, again not part of emission calculation but it is showing the health of the engine. Peak firing pressure PFP, which is representation of mechanical load on the powertrain of the engine. Fuel line pressure and injector line pressure are to understand the fuel pump performance and understand the quality or the specification parameter of FI system. And these parameters will help to improve emission performance, which are very much related to the subject in case they are really required. Next slide. On this slide, in the tabular form, the various temperature are mentioned to be required to calculate other terms like humidity parameters, relative humidity, specific humidity, vapor pressures and density of air etc. Here in this slide, I would like to bring your attention to important parameter which is called weighing factor, and these are defined in standard such as ISO 8178 and which can be referred depend upon the application which we are considering. Weighing factor are related to usage pattern of the application during the lifetime. So accordingly for various loads and speed conditions, the different weighing factor is defined. In this case, we will more dealing about 8 mode cycle which is applicable for off-road application. I will also just touch base to genset, which is mostly refer to 5 mode emission cycle. The other inputs, additional inputs are required for the calculation purpose such as engine bore area and engine stroke. Here we are coming to section end, and we will be going to next video where we will discuss section 2. We are coming to second part of the presentation where output parameters will be explained. Observed power now here is to be calculated from observed torque on the dynamometer panel in case of engine being tested on dynamometer. In case of generating set where alternator and engines are being assembled together for electrical output, the load is from the grid of resistance by heaters or maybe by electrical bulbs where you get electrical power, whereas on dynamometer we get mechanical power. BMEP is representative parameter to get idea of average mechanical load on the powertrain. Fuel flow parameter is calculated based on the input which was measured, and these parameters are further used to understand fuel consumption and also utilized to calculate correction factor. Engine parameters are always corrected to STP conditions so that engine specification can be compared at same reference conditions for the equivalent engines from various OEMs. Hence, corrected parameters are generally calculated using correction factor, which is function of temperature, pressure and fuel rate. Now here lambda is excess air ratio indicating excess quantity of air over ideal requirement for ideal combustion reaction, and as we all know, in case of diesel engine necessarily at critical operating mode minimum 1.3 value is desirable. Volumetric efficiency is again one of the performance indicator parameter towards breathing performance of engine. Emission parameters in mass terms are required to be converted from ppm values, as we are all interested towards cycle average emission, and those are related to weighing factor associated with the different operating modes as defined by standard, and accordingly we need to reduce the ppm values to the proportion of weighing factor. Now here The parameters listed are temperature and pressure factors which have been defined as per standards towards calculation of overall engine power correction factor. As per application, correction factor are defined multiplication of temperature and pressure factor having A and B indices to the respective ratios. FM term here is called engine factor and CF is given by FA raised to FM, and A is equal to 1 and B is equal to zero point 0.7 for naturally aspirated engine, while A is equal to say zero point 0.7 and B is equal to 1.5 for turbocharged engine. Additional output parameters are required as the air density, water vapor pressure, which will be further utilized for humidity derivations. Similar to NOx, SC, CO, FSN or smoke input is used to find out soot or PM content in exhaust gases. Now here, our next output parameters are calculation of mass airflow from volumetric flow, which was captured as measurement parameters mentioned in the input list. Stoichiometric air fuel ratio can directly be considered as 14.5, or it can be calculated from a combustion balance equation as well. Now here John Haywood can be referred for further understanding, and especially the equation 3.5 explain the detail about the ideal combustion equation. As I mentioned earlier, humidity parameters are important to apply the emission correction factors. Accordingly, we need correction factor for emission pollutants. Total gas flow is represented here as mass of air and mass of exhaust gas. We need to correct NOx and CO with the help of respective correction factor for various further calculations. Coming to next slide, here some more parameters like FA ratio, then FA exhaust ratio has been mentioned over here. Especially FA is F to A ratio, which is observed from fuel consumption and air consumption from the engine measurement. To check the emission instrumentation calibration quality and accuracy of measurement, there is a way to calculate another FA based on exhaust composition. So these are all the various output parameters are required to be calculated as far as overall engine performance and to calculate the various emissions parameters. And here we are discussing section 3 of part 1, and more focus on formulations required to calculate engine and emission performance parameter. First parameter is observed power, is a function of torque and speed associated with dynamometer constant. Kilowatt to HP conversion can be included by introducing conversion factor of 1 HP equivalent to 0.735 or 0.745 kilowatt, depends on metric or British HP representation, but mostly these days only metric HP is dealt upon. Brake mean effective pressure, which is BMEP, is average pressure is supposed to be acted on piston top, and which is function of power distributed over the swept volume per power stroke. Fuel flow needs to be calculated in terms of mass rate specific to unit power per time towards fuel consumption, and volume rate helping to set the FIP flow requirement. To calculate correction factor, various guidelines are available in different standards, and as respect to type of application, different formulas to be selected. I have already explained the background on the same in the previous slides. Even though the corrected power does not a part of emission calculation, however, towards comparison purpose, of equivalent engine and declaration of power at standard reference condition, the correction factor is calculated. As described earlier, serial 10 and 11 form the atmospheric factor and serial number 12 is engine factor. Depending upon the application, correction factor formula changes with respect to indices of values A and B. Other formulas for density, water vapor pressure, AFR and volumetric efficiency are shown in the table. Lambda is mentioned earlier as the excess air ratio and defined by tested air fuel ratio over the theoretical air fuel ratio. Volumetric efficiency is breathing ability of the engine given in serial number 17, which is defined by the actual mass intake into the engine to the theoretical mass flow supposed to be entered into the engine at the test condition. Going to the next slide, even though dry and wet basis air flow are calculated, but humid flow is considered for total gas flow calculation, and accordingly the quantity of pollutant by the engine. Relative humidity is related with water vapor pressure and saturated pressure, where the ratio of the same is the value of relative humidity. Similarly, specific humidity can be calculated by formula shown at serial number 22. Now, important calculation for correction factor for CO and NOx is explained in serial number 23 and 24. I have used some product values or variable terms like C1, C2 in these complex formulas since it constitutes various parameters, and I thought to explain on the same in part 2 section of this series. And in between you can have action here to thought over the same and making you curious about the same. Finally, our interest is to calculate specific, corrected and weighted values for all the pollutants. And in this slide we have this parameter for NOx, CO and hydrocarbon SC. Once they are calculated for one mode with the process explained so far, it needs to be repeated for the all modes, whether it is 8 modes for off-road application engine or 5 modes for generating set application engine. Let me explain one case for NOx here. We have ppm values of NOx available from measurement. We will convert this value into gm with the help of coefficient and followed by multiplication by correction factor and weighing factor. Once we get this value, it will be divided by observed power to get specific emission value in gram per kilowatt per hour. Now the same process is applied to other emission pollutant as well. Going to next slide. Now we talk about the soot. In case of soot, the measurement of smoke is converted in specific soot parameter and subsequently represent this value as a particular matter parameter, that is PM. For explanation, this topic would be lengthier, but due to time and video size, I have some shortcut towards explanation, but I have covered fairly so that the process should be clear. Finally, FA ratio based on test reading and another FA ratio parameters can be calculated on the basis of gas composition parameters which can be recorded during the testing, and these two values can be calculated and compared to check the balance and understand the accuracy of the measurement. We are coming to the end of part 1 presentation. I have action for you. If you have data set, use above formulations up to the level we have discussed in this part, and the remaining calculation can be completed after part 2 of this series. In second part, we will have coverage of the listed topic which I mentioned in this slide. More discussion on some product values or the terms which we have considered as C1 and C2. Any arbitrary data to showcase how independent values for each mode pollutant values can be calculated will be also part of the section 2. Converting them as a cycle average and comparing with norms values so that test or design engineer decision that engine comply with norms what is reserve available, will it comply DA factor, etc. So here are some of the references which have been utilized and referred and read through towards preparing the above content. Hit like and bell icon button and subscribe to this channel so that you will get notification for future videos on various other technical topics. Once again, thank you very much.